A rifle is aimed horizontally at a target 50 meters away. The bullet hits the target 2 centimeters below the aim point. What was the bullet's flight time and what was the bullet's speed as it left the barrel? So let's go ahead and draw a diagram to show what's going on. Okay, so here's our picture. The bullet is leaving with some initial velocity, v initial, and we need to figure that out. The target is 50 meters away. It says that the bullet hits the target 2 centimeters below the aim point, so that means that this is going to be our delta y. Again, we know that there isn't any horizontal acceleration after the bullet leaves the rifle, and while it's in the air, we're going to have acceleration equal to g. So let's make down the positive y direction, and let's make to the right the positive x direction. Okay, so let's go ahead and write down the known values. So we have our x values and we have our y values. So in the x direction, we have delta x is equal to 50 meters. We have acceleration in the x direction is 0. We have v initial in the x is equal to v initial, which is equal to, well, we don't know that, but we do know that the horizontal velocity is the initial velocity, which means that the initial velocity in the y direction must be 0. In the y direction, we know acceleration is equal to g, and we'll just use 10 for that. And we know that delta y is equal to 2 centimeters, which is equal to 0.02 meter. And I think that's all we know. So we want to find two things. We want to find the bullet's flight time, so that's time, and that's for part A. And we want to find the initial velocity, v initial, which again is equal to the horizontal velocity. They're the same number. Okay, so let's pick an equation that has the thing in it that we're trying to find. And it might not be clear which direction to start with here. So just go ahead and pick one. And you might get stuck if you pick the wrong one, and that's okay. You might need to use it later. So let's go ahead and use this equation. Let's use delta y equals v initial y times time plus 1/2 ay times time squared. The reason I picked this one is because I know that this is going to be 0. V initial y is 0. Ay is going to be g. So let's rewrite this as delta y equals 1/2 g t squared. So now I can solve for time because I know all of those things there. So I'm going to have time squared is equal to 2 delta y over g. And now I can square root both sides to get t is equal to 2 delta y over g square root. And we can plug numbers in. So 2 times delta y is equal to 0.02 meter. And g is going to be 10. And then we square root all of that. And we end up with 0.063 seconds. Part B, we're trying to find v initial. And v initial is made up of the x and y components, right? Technically, v initial would equal v initial x squared plus v initial y squared, square rooted, using Pythagorean theorem, but v initial y is 0. So really all we're trying to do is figure out what the horizontal component of v initial is, and that's v initial. So let's pick an x direction equation that has that value in it. I'm going to pick the wrong equation to start with just to show you one thing. So I'm going to pick this equation, v final x equals v initial x plus ax times time. So if I try to use this equation, acceleration in the x direction is 0, so that term goes away. And all I'm left with is v final x equals v initial x. So all this is really telling me is that the x direction velocity, the horizontal velocity, is constant. It doesn't change. So it doesn't really tell me anything useful here. It's something that we assumed by saying acceleration in the x direction is 0. So the right equation to start with is this one. Delta x equals v initial xt plus 1/2 ax t squared. And ax is 0, so that whole thing goes away. And then I can solve for v initial x and get delta x over t. And then plugging those numbers in, we have delta x is 50. And I'm using the time that I had from part A. So just a quick note here, if you are taking an assessment and you mess up on part A and you get the wrong time, as long as you are consistent by using this time that you got from part A in part B, you're not going to lose any points on part B. So plugging in that time, 0.063 seconds, let's see what we get. So plugging that in, we get 794 meter per second. So a good idea here is to think about whether or not this answer makes sense. One way you could do that, if you're not taking a test necessarily, but if you're solving a problem and you want to check to see if this makes sense, let's compare it to a different speed. So let's look up maybe the average speed of a bullet, or we could look up something like a constant, maybe the speed of sound through air, and see how that compares. So just doing a Google search, we see that from the Wikipedia page, firearm muzzle velocities range from approximately 120 meter per second to 370 meter per second in black powder muskets to more than 1200 meter per second in modern rifles and high velocity cartridges. So this is an acceptable range then.